Hello everyone, welcome to GeoNodes Challenge Series, where I dig deeper into the potential of geometry nodes to show you what amazing things you can do with this tool that the Blender has, procedural modeling and procedural animation tool. And in this series, this 6-part series, we will recreate this awesome looking animation that you see here, this holographic planet that has all this procedural setup on it. You have these flight paths that are generated procedurally and you can change. You have those points of impact that take into account the tracers on the flight path. You have that cool particles effects that go inside of the planet and the ones that are going in the bottom half and all that good stuff. And this is in response to a request from a long-time viewer on this channel, Roman. He wanted to see how you can make this kind of flight path animation with geometry nodes. So I came up with this project, and I also have another one it's really cool, and I'm working on it, and you will see it soon enough. Before we start, as usual, I want to thank all of you for supporting this channel, for subscribing to the videos, liking them, commenting, and also a big thank you for all of you that are purchasing the projects from Gumroad. This is a very good way to support what I'm doing and help me keep doing it. And as usual, this project file that you see right now on the screen will be available on Gumroad for you to purchase, so you can play with this fully procedural setup. And like I said, you have a lot of options. You can, for example, control this particle effect that goes down here, its animation, density, and all that good stuff. You can control these flight paths. You can control how many of them are. You can choose their random distribution. You can also control these tracers that go on top of the flight paths, including their length, not only the animation, and a lot of other sides that you have here to control, like the bending of these flight paths or their thickness. And in the shader, because you have these awesome shaders here, you get this really cool holographic effect that it's connected to the geometry nodes. So when you start to change things there, things start to change here. For example, when you have that reveal animation, and lots and lots of other cool stuff. But anyway, even if you don't purchase the project file, don't worry, just follow this series and you will get to see everything. So this is the part one. So let's see what exactly are we going to be doing in this. And we will start with the beginning, how we can generate these flight paths that you see here. This is the meat of this tutorial. How can we generate this path in a random fashion? What a question arise? How can we answer those questions? And so on and so forth. So let's move to a clean file. And now that we are in a new file, I'm checking that I have screencast enabled, so you can see what I press. And let's get to the first point, how to approach the problem, questions to ask. So we want to have a planet. Let's take an icosphere and plug it here. So now we have this beginning of a planet. And we want to answer basically 2 questions. And the question number 1 is how to get some lines stick to the mesh, and how can we make those lines bend away from the mesh. So no matter how they get stuck to the mesh, we want them to bend away from the mesh, not inside the mesh. So a quick word on this. I'm gonna show you what I did, but there are more than one solution. I want to talk a little bit about other approaches. You may find it helpful in your projects. That's why I'm showing you. So you may have a bunch of lines already that are distributed somehow in a random fashion around your mesh. Let's say something like this. One way to make them stick to the mesh is to use proximity or raycast. You can find them here. You have this geometry proximity and raycast. You can use them to make them stick to the surface of the mesh. And then you can create a setup to bend them. That's one approach. Another approach is to create a bunch of lines. You don't care about the location, and then you can take the position of the points of this mesh in a random fashion using, for example, a math done on the index. So you get the position of some random points of the mesh by doing a random stuff with the index, and you transfer those positions to the ends of the segments of the lines. So those segments will be basically ported here on your mesh. That's another approach that can have benefits depending on what you do. But after thinking on these methods, I realized that there is an easier way to do this. We already have this data here, and if we look in the here in the wireframe view, we basically have some edges here. So why not borrow this data from our mesh to create our setup? So let's do a subdivision here. Now we have a little bit more data to the mesh, and I'm gonna add a geometry join geometry node here, and let's basically do this thing, adding the lines. So we have these lines, and we can do the following thing. We can take a geometry and delete geometry, switch this one to edge, and now basically we have a control here that allows us to decide how many edges we want to delete. And the simple control for that is a random value. We can switch it to Boolean and plug this one here. And as soon as we do this, we basically get the edges that we need. But don't worry about these faces that are here. It's gonna be easy to get rid of them. But first, let's just decrease the number of lines, because we don't really need so many. We can even leave these faces for a while so you can see what happens. First and foremost, we don't really need a mesh. Now we have a mesh here. But what we actually want is splines, because later on we want to have an easy way to track those lines, and splines curves offer you a much better way to do this kind of thing. So let's just take this mesh and do mesh to curve. And as soon as we do this, first of all, we get rid of the faces, as you can see, because now we have just lines. And second of all, we got some curves that we can play with later on. That is something that I'm going to show you in the next video, how you can do those cool tracing lines that you saw in the video. But for now, let's just reduce this number of lines and get something like this. And of course, we can simply reconnect our mesh here to see our geometry. So I'm going to reconnect this one, but I'm just going to hide it for now, just to keep it out of the way and not interfere with our work. Another thing that I want to do, given the fact that we want to build tracers on every single segment, and we also want to bend each and every segment, I want this to be separated, because right now they are kind of connected here, but this is not what I want. So I can just use a split node. If I can find it here in the mesh, we have split edges. And what this does, just pay attention to the data here. As soon as we plug this one here, as you can see, we have more splines now. Even though visually nothing seems to change, now these segments are, these lines are each and every one of them a segment. So this is exactly what we want. It's going to help us later, and it's going to help us to bend the lines right now. So this is our control here for the number of lines. At the end of this video, I'm going to show you how I expose the parameters for this, but for now, let's move to the next point and make these lines bend and add a little bit of variation to that bend. So we don't want all of them to bend at some same radius. We want some of them to bend little less, other one to bend more. That's going to make things look a lot interesting, more interesting. So let me save. So how exactly can we bend these lines? Well, how would you do it? I don't know. You can put it in a comment. I'm going to show you my method. So let me put a frame on this one. This is our lines. I'm going to rename this in offline mode, so I don't waste your time with that. Right now, if we look at this data here, we see we have 19 splines and 38 control points. So one thing that should be obvious, if we divide 38 by 2, we will get 19. And if we play with this value to get less data, let's see, we have 17 splines and 34 points, and we can play even more with this, and you get the point, 12 and 24. We will have twice as many points as splines. That tells us that our splines are composed of 2 points. So that's very good for us, because if we want to bend, an easy way to bend it is to add a control point, meaning change the number of points, and then isolate that point, make a mask for it, and move that one in this direction or this direction. And that's gonna give us the bending. So let's do just that. Let's add a curve, a resample curve. I'm gonna plug this one here. And as you can see, right now we have 10 points. So 12 splines, 120 points, but we only want 3. So now we have 3 points. And that's very important, because if we look at the control points, each spline will have 0, 1, 2 points, this being the index of those points. So that's important, because the middle point will have an index of 1. So let's select that. And for that, we have a node that we can use. It's a little bit misleading. We need the index, but we can't use this index, because this index is going to give us these values here, as you can see, from 0 to 35. But we basically want the index for each spline individually, and this one is not going to give us that. But if we go to the curve, we have this spline parameter. That's a little bit misleading in this case, because it doesn't immediately tell you that it has this output that we want from here. So let's use this drag and drop menu, and I'm gonna do equal. That's gonna give me this node here that is basically taking from utilities, compare, and set to the right type and the right operation. So now I can press Ctrl H to hide the inputs I don't care about. and say if this is equal to 1. Remember, this is 0, 1, 2. We care about the middle one, the 1. Now we have a nice mask that isolates for each and every segment the middle point. So now we can do whatever we want with that point. And what exactly we want to do with this one? We want to change its position. So how can we do this? We can use a geometry, set position, plug this one here. And right now we move everything, but as soon as we plug this mask here, as you can see, we move only the middle points. So how can we push this away from the mesh? Well, there is an easy way to do this. You can use the normals of this data here, or you can do something else. You can use the position of the point and multiply it by itself, and that's gonna push it in the same direction that this position has. So let me show you what I exactly mean. We can take the position here, and if we plug it here, nothing happens because we basically move nothing nowhere. But if we add a vector math node here, plug it inside here and switch it to scale, we will start to multiply the position of these points like this. So now this is going to be our bending factor. Awesome. So let me take for the moment a value. I'm going to give it a green value, so I know that it's something that I want to change. And I'm going to put this one to more than 1 to push it outside, because if you give it less, it's going to push it to inside, more is going to push it to outside. So awesome. Now we have this cool setup. Let's just select all of these nodes, including this, and make a frame so we know that this is something else. And let's look at what we achieved. We get this setup here. This is too pointy. We want to curve this to make it nice and smooth. So how can we do this? Well, this is a spline. So if this is a spline, that means we have control handles depending on the type of the spline. So if we set this spline type to Bezier, nothing happens. The curve keeps its shape. But now we can use a set handles type. If I can look it, yep, here. And as soon as we do this, let me hide this mesh again, we get this nice rounded setup. If we close this one, as you can see, we get an error message because it tells us that this is not a Bezier type. It's actually a poly type. That's why it's not working. So if we switch this one to poly, it's not going to work. To NURBS, not going to work. And this new type, Cardinal ROM, is not going to work. But this one, actually, hey, I didn't know they introduced that. Yeah, you can use this Cardinal ROM if you want, and you don't need this node anymore. Yeah, it's giving you a different type of bend. But for the sake of keeping it consistent with what I did in the file, in the original project, I'm going to leave it like this. So we are getting closer to achieving the result that we want, and that is to get a random number of lines here. So we got it, and we have this control that puts more lines or less lines on our mesh. And now we want to do one more thing, and that is to give different values for the curvature of each and every one of these splines. So how can we get that effect? Well, we can change this static value, this little circle, to something diamondy like this. And I'm going to show you immediately what I mean. Let me change the color of this frame so we can see it inside of that frame. By the way, these are presets that I created for the color. You can basically go here, change it to any color you want, and once you did that, you can do plus to new preset and give it a name, and then you get this thing here. So we don't want a static value, we want a random value. So let's do a random value. I'm going to plug it here. Everything disappears because we have something that doesn't work the way we want. If we look here, we see the bending going inside because we have a 0 to 1 values. But we want to have some bending, let's say 1.1, and we want to have a maximum, let's say like 2. 2 is too much. 1.4, yeah. And as you can see, now some of them bend more, some of them bend less, and this seed is gonna give us different results. So let me make this one a green node. So now we have this control here, and this is also a green node because it's a control here. So this is it for this part. Stay tuned to watch the next part where we will go into doing the tracing, and that's going to be really cool because we will build these tracers that will follow the spline. We will fix a few problems that appeared during doing that, and we also going to create a procedural setup that will make some of these tracers go faster, some of them will go slower, some of them will wait longer before we reappear, some of them will wait less. So that's going to be really cool and really useful to you. So stay tuned for that part. But now I want to get to this part. I'm going to show you quickly what I did here, and I'm going to show you how to expose some parameters from this setup. So basically we started with an icosphere. We borrowed some of its edges. We deleted the one that we didn't want using a random value here. Then we splitted the edges to make sure that we get a segment for each edge. And when we took these segments, we resample it to 3 points to get a middle point. Then we use the position of that middle point that originally was here to multiply it by its self, something like that. Basically, we scaled the position to more than 1, and that pushed that point there. And in order to make it nice and smooth, we used this set to Bezier and set handle type. And as I found out right now, you can use this new type, cut more chrome. I didn't knew that they managed to implement that. I knew from the developers blogs that they plan to do that, but yeah, that was new for me also. Okay, so I'm gonna save this file and I'm gonna show you again the finished project and show you the parameters implemented there. Okay, I'm back in the original file and we care about a few of these parameters. So let's look at the globe first. We have a hologram radius exposed here that allows us to increase or decrease the size of the whole globe. As you can see, we have the same setup with 2 subdivisions that allow us to create these splines. And I created this optimizing the viewport because I wanted to make everything smoother. It's also important, the smoothness, because when we will create these points of contact on the mesh, depending on the resolution, as you can see, they will get smoother or less smooth when we send data to the shader. So that part is important. And also something that I haven't showed you, I'm going to show you now. We have this setup. I exposed the seed and random value. So we can change the amount. If we look here, we have a flight lines amount here, and the tooltip and the seed. And in order to make things make more sense, because at 0 you have 0 lines, at 1 you have the maximum amount of lines. which was basically the opposite of what this node gave us, I added this not. So I inverted basically the operation. One more thing that I haven't showed you, because I forgot, honestly, was that the moment you subdivide this mesh, the globe, to make it more smooth, it also is gonna make it less bigger. It's gonna decrease the radius. As I'm sure you all know, when you subdivide something, it's gonna make it smaller. So that made these lines stick to the outside. So I had to do something to make them go back and stick to the mesh. So what I did was to take the globe mesh, the subdivided mesh, the one that we see here, and taking that data, I did a proximity check on it and used the position. Basically, that gave me the distance between the closest point on this spline and the surface. So I used that position from there to move the points to stick to the mesh. And this knot node that you see here is basically inverting the mask that selected the middle point, because this mask that allowed us to bend the points selected the middle point, and I wanted the points to stick to the surface, only the end points. I didn't want to cancel the bending. So if I'm muting this line, as you can see, everything gets flattened, because all these lines that you see here, they basically are also made to stick to the mesh. But as soon as I activate this, we protect the position of this point in the middle, and we just make these ends stuck to the mesh. So this setup, looking at the subdivided geometry and masking out the middle point, make sure that these contact points, start and end, get stuck to the mesh no matter how much subdivisions we apply. Without this setup, so if I mute this node, we get this result, because we are basically sticking to the original mesh, this mesh here that it's been subdivided. So if I mute this node, we can see what happens. This is the unsubdivided mesh, and this is the subdivided mesh. So this setup here makes sure that everything glues nicely together. So this is it for this part. We covered these points that you see here. In the next video, like I said, we are going to look at the tracers. How can we offset an animation, how you can delay an animation, and all that good stuff. Until then, thank you very much for watching this video. I really hope you find the information useful. Please leave me your comments, and I'm gonna read